Hello? Can you listen me? Yeah? Okay. Welcome to this talk. My name is José San Román. I'm currently the CIO of ING Spain. Okay, actually, I'm 3 months new by CIO. Let's see what happened after this talk. The talk is going to be in English because we in ING use English as the default language in IT because we are an international organization and we want our people to speak English without any problem, okay? In any case, we can switch to Espanol if we have problems, and do not hesitate to do questions in Spanish. We can later on translate. I'm going to try to interact with you a little bit using candies. I have here 8 shots. I will be using them during the talk to push you a little bit to interact with me. The people who knows me knows this. I usually use this trick to ensure the proper interaction. So if you're looking at my eyes, probably I will go over there to ask you a little bit. The title of the talk is Bank from the Outside, Startup in the Inside, Developing Software at Scale. And this is a little bit what I've been studying during the last year, and I want to share you these thoughts, how I think we should develop software at scale. Okay, so starting the talk, I think we should a little bit put in the context what do we understand about developing software at scale. I want to share this definition with you, or at least my definition, so we are at the same level of understanding. What do we see here? I'm not going to give Candy to answer this question because it's quite easy. We see a lot of people. Let's move to the IT domain. We see a lot of engineers. All of that are engineers. So many engineers working in a product. Okay. What is that? What is coming to your mind regarding this image? This is a vehicle, of course. That's good. And it's a speed, velocity. So we're talking about a lot of engineers delivering a product with speed. Okay? And what is that? It's a lens that helps us to focus. No? We're focusing on something. What we should focus on? We should focus on customers. We're delivering a product to customers. So we need to have customer focus. And with these 3 ideas, I built a simple definition that is a lot of teams. Let's think about more than 50. Having the speed and the customer focus of a startup. I'm connecting with the title of the talk. But we know that when software ages, becomes a mess. And this is the right way to say that, but appears to atrophy. Okay, becomes messy because everybody is changing that software, and this is a little bit the journey I think that happens when you're growing your code base. So you find that it's not easy to assess the impact of the changes you are doing, and when you find that and you are in that situation, you create a kind of methodology to minimize the impact of your changes. That is the minimum impact work style. I usually do that. But what is happening? That is bringing complexity into the code base, and more complexity will reduce our speed. That's a little bit the journey when you have a lot of engineers working in a code base without taking into account how to deliver at scale. Okay, so the question is how to scale. This image is a little bit to share with you the concept of doing small pieces. If you do the software in small pieces, you will be able to reduce the problem. But the thing is that those pieces should be the system itself. And that's the concept of decoupling the software. Okay, which are the three things I think, three attributes I think decoupled software has. Okay. The first one, you share the state with a clear contract. The second one, you're able to build, test, and deploy that piece in an independent way. The third, you're able to consume other pieces of the system without having too much knowledge. Okay? And this software will be built by what I name decoupled teams. Decoupled teams produce decoupled software. A decoupled team has three characteristics. The first one, again, each team, it's a complete organization in itself. So I'm applying the same concept I was using to the decoupled software to the decoupled teams. The second one, how you implement that piece should not be important from the outside. So the teams can have a little bit of autonomy to decide how to implement internally that piece. And the third, in order to ensure that you align all those teams creating that product, you should rely on a platform to ensure the proper alignment. So it is not fully freedom to do the things. You have a blueprint of things you can consume relying on that platform. But I'm going to use my first shot. What a platform is. There are different definitions depending the context you are. The first one is the one that comes to my mind from the business perspective. There is a place where you connect needs. Let's put an example. Let's think about Uber. Uber is a platform that is connecting the need of drivers with the need of transportation. Okay? But I'm not thinking about that kind of definition because we are IT. I'm thinking about the IT definition. So what is coming to your mind when you see this image? I'm using this shot to the person that responds to this question. What is coming to your mind? A stage. Who said that? Who was? Ruben? Who was? Over there. Wow. Who was? Raise the hand. Yep. The candy for you. So this is a stage. This is where the people perform, where the things happen. And that's a platform from the IT perspective. I was able to find this definition in the lexical. You have the reference over there in the lexical dictionary. This is a dictionary by Oxford that says a platform is a surface where people or things can stand, can perform. And that's the concept of platform I was referring to. Okay, we saw a little bit the characteristics of a decoupled team. What about the organization? Who knows the Conway's law? Raise your hand. Conway's law? Okay. So I'm using Conway's law to explain a little bit how I think we should organize the teams in order to be able to produce decoupled software. And here you have the Conway's law. So Conway's law says organizations which design systems are constrained by the communication structures they have. I'm going to translate this to the IT language. You will see in your code base who are fighting with who. You will see how teams protect with others because of the way they are creating the source code. So source code will be an image of your organization. But the thing is, let's try to invert the Conway law. How we can use the Conway law in a reverse mode to define the organization we should have to ensure we are building decoupled software. And this is the definition I have. So build an organization that promotes the architecture you want to have, the desired architecture, the target you want to have. And this is a little bit having kind of horizontal and vertical mindset to drive kind of efficiency. You can see here a lot of suitcases, but they are well organized. But they are only organized in a vertical and horizontal mindset. And why that is helping us? I'm going to put a clear example. Okay, here you can see a little bit of system which is relying on an account management system, and this system has three products: the mortgages, the loans, and the debit cards. All these three products are relying on the account management system, but only two are using the risk engine. So I'm using this horizontal and vertical mindset to define the domains of the platform I want to build in a decoupled way. But if I apply this at team levels, we can go to the mortgages domain and see how that team is organized, because each team is a system itself, it's an organization itself. So you can see that simulation and data collection is relying on the risk engine, but the origination and the servicing part of the product is relying on a case manager, which will be relying on the risk engine. But we have a debit card that is only relying on the account management system. So we're having this horizontal and vertical mindset to create an organization that will promote the architecture we want to have. Okay, but there is no good or bad organization. All the organizations usually have a few handicaps that you need to know and manage them. And this one has at least three that I consider they are very, very important to manage. Okay? These handicaps are: the first one, you are moving the complexity to the operation side. Okay? When you are decoupling and building small pieces, then you need to operate them. You have more pieces to operate. You are moving complexity to that part of the system. You are creating more dependencies. And we know that dependencies will slow us down. And the third one, we are creating a system in a way, in a manner that is not easy to test. Okay? I would like to deep dive in all these handicaps, but I have no time, so I will give recipes to the first and the second one. I will deep dive on the third one because I'm a fan of operational excellence and quality assurance. So I will deep dive on the third one. Probably I will prepare another talk with the other ones for their code motions. Let's talk about the recipes of the complex operations. What is coming to your mind with this image? What do you think I'm going to say because of this image? Who wants to answer? Dependencies? Could be. in any case. You got it. Okay, this is a sidecar, no? And there is a pattern that is called sidecar pattern. The sidecar pattern is like this way. You will have your business functionality as much as isolated as you can with all the things that will be provided by the platform. And the important thing here is to have your business functionality as cleaner as possible, so only includes the business rules you want to implement. It will help you a lot in the future when you want to move forward your product. And in the sidecar, you will have other features that are like configuration, networking, retries, communications, load balancing, whatever. But that's not your business functionality. That should be provided by the platform. So you're putting that aside in your sidecar, and you will relay on the platform. That will provide you all those kind of features, ensuring the proper alignment in between all the verticals. Okay? Let's talk about dependencies. The second one. What I'm trying to say with this image is dependencies will slow you down, so try to avoid as much as possible. And what was coming to my mind when I was preparing the talk regarding dependencies is trying to explain you that economies of scale does not apply to long-term software. What I'm meaning with that, reuse is not a good idea. If you want to reuse because applying economy of scale to reduce the cost of your delivery, you will be in a problem in the future. Because economies of scale does not apply to software. Trust me. Because you will create more dependencies. And the more dependencies you have, it will be really, really bad for your product because you will need to deal with them. So, my proposal here is make sure you only reuse when you have a really, really strong requirement in your system. Let's go back to the example regarding, for example, the risk engine and the mortgages and loans products. We are reusing the risk engine. Yeah, that's true. But we have a strong requirement over there, which is we want to have a customer view in terms of risk. So I don't want to give a loan if the customer already have a big mortgage. Because risk is customers, should have a customer view, not a product view. That's why I'm reusing the risk engine in those domains. But if you have dependencies, okay, try to avoid inter-domain dependencies. Mortgages shouldn't depend with loans or with cards. Those are inter-domain. Allow only vertical dependencies. The mortgage depends on the risk engine on the account management system and not in an horizontal way. Because horizontal dependencies will bring you a lot of complexity, and you won't be able to deal with that complexity later on. So dependencies should always go in a vertical way. I'm coming again to the horizontal and vertical mindset I was talking. Another important thing when talking about dependencies is applying the dependency inversion principle. We already know this is coming from the solid attributes, the D of the solid, dependency inversion, where we put an interface on the client. So we move the interface to the client. The client has the power of defining and changing the interface. So we're inverting the dependency. We can do that the same at organizational level, inverting the dependencies. What's that? So mortgages will not depend on the account management system. Account management system will depend on the product. Because what we're looking for is we need to ensure that the horizontal blocks really implement the customer needs. So we're moving towards that customer focus we were talking at the beginning of the talk. How do we ensure we have customer focus? Because the requirements are coming from the products, not from the platform, not from the building blocks we are sharing in the platform. And with that, we are avoiding a little bit the Jagni principle. Who knows what is the Jagni principle? Who can tell to me? You're not gonna need it. That's great. Be careful. Thanks. Awesome. You're not gonna need it. When you're building horizontal blocks, you need to ensure you're implemented the proper use case of the people, of the teams that are gonna consume your APIs, not the other way around. So the products will rely on your functionality. So make sure you're embedding the dependencies. You're moving the interfaces to the products. Okay, let's go to the last part. Not easy to test. This is where I'm gonna deep dive. And usually here, people start thinking about the testing parameter. And I think we should get rid of that kind of concepts. Unit test, integration test, UI test. That is too complex because there are different definitions of integration test, UI test. So my proposal here is to use different kind of definition. I will show you later on. What is coming to your mind with this image? Remember, the answer is at the beginning of the talk, eh? What is coming to your mind? What you can see here? What? Who said complexity? Complexity, eh? I said that at the beginning of the talk. Complexity. Look at that mess. They were putting more air conditioning in the building, but they were creating that work style of, okay, how can I put my air conditioner without disturbing my neighborhood, and without having a problem with them, eh? And look at that mess. It's amazing. So let's go back to the type test definition. Okay, I'm bringing you this concept, integrated tests, not integration, integrated tests. You can find a reference over here of these definitions. These are not mine. These are tests that depend on the implementation of more than one piece. Simple. Your test depends on more than one piece. Integrated test. And what happened with these tests? Who can answer me? What happened? Fragile? Who said that? Okay, let's put the good word. They're flaky. They are very flaky. And flaky tests will kill you. Let's look, because if I bring something from Google, you will trust me more. So I was looking for something to ensure that you were trusting this message, because it's from Google. This is a graph where they cross the size of the test. They don't use, because of the complexity of the definitions, unit testing, integration testing, and UI testing. They use small, medium, big, simple, and the probability of being flaky. There's a correlation. It's clear. The bigger the test, the flaky it is. Cool. flaky test will kill you. Let's see. This journey is from an author that is called, that is named Gorko. I'm a fan of, but look at that, 2010. I'm really old, but it's still valid. This is a team doing UI tests, and they start, and it's crossing a little bit their journey with their happiness of the team. They agree they should automate. That's clear. They try to find a couple tools that can help them doing automation. In this case, Selenium, Fitness. Probably Fitness is not suitable right now. Cucumber, whatever. Look at that. No hands. Incredible. What happened later on? They start having problems with their tests because they are not able to maintain them. I don't want to be that team. Say in my business, we can't implement your features because it would take too long, because I need to change so many tests. What is the real journey is happening here? Okay, you start using unit tests. We know the testing parameter from Micron. All of us know that. That is the theory. You start doing unit tests, great. 100% of coverage. Amazing. You find bugs. No problem. Let's do some integration tests. We know the parameter. We start doing integration tests. We still find bugs. No problem. We still have the last test we should do, and it comes from the parameter. We start doing UI tests, killing ourselves. And then this integration test and UI test becomes unstable, and they bring a lot of false positives. We realize also that they are not easy to maintain. What happened later on? Who disabled a test in the last 3 months? Raise your hands. Come on, guys. Shit happens. Why we're doing this? This is not helping us to manage the quality of the product. Okay, let's see how we can define a better strategy than that journey. I have 3 shots. I want to use this one because this is a good one. What is bringing to your mind because of this image? Isolation. Who said that? Who said that? Please go. I'm gonna. the one is raising the hand. So help me on that. A house in isolation. Amazing house, eh? It's not mine, eh? Isolated tests. Integrated test, isolated test. Quite easy to remember. Only 2. Test that does not have side effects. If it is green, it is green. I'm going to say something in English, but it's because of this. It's related to Spanish people. When you say something twice, is because it's really, really good. When you say something is very, very good, it's because it's amazing. In Spanish, for example, we say jamón, jamón. You have, this is leather. No, it's leather, leather. So when we say twice, it's because these kind of tests are very, very good. And unit tests are the better isolated tests. Look at the figures. This is not the first time I use this slide in my talks because I love this number. 77% of the bugs that you can find in production can be detected using a simple unit test. 77. You have the reference over there of the paper, and you can read it. Amazing figure. Why we are not using more and more unit tests? I know it's not easy. You need to find a good strategy. I'm bringing this. And the question is, when you are decoupling software, you have a lot of integration points. How can you check those integration points? Okay, let's remember a little bit unit testing work. We usually use stubs to test behaviors. Remember, a stub is a test double that returns candidate responses. So we can check the state of an object using those stubs. Use stubs to test behavior. We know that. Okay. Use mocks to test collaborations. So we have one part of the system that collaborates with other parts, and we need to check if they are properly collaborating in between them. And we will use mocks. Mocks are test doubles that help us checking expectations, no? How those objects are collaborating. How many times I'm calling a method with certain parameters. Is happening call that I'm expecting and I'm configuring in the expectations of the mock? That's cool. I think all of you know this. And you also know this principle. Don't mock what you don't own. Let me elaborate a little bit. What this principle is saying, when I try to refine that, is how can I ensure that I'm checking the mocking assumptions we are doing when we are using mocks and stubs. If we do not check those assumptions somewhere in our unit tests, we will be mocking what we don't know. I have two thoughts. I need to think, but this is a good one. So, what I'm trying to say with this image, contract. Who said a contract? Who was the first one? You. They're signing a contract. But what a contract is? Let's think about that. A contract not only includes the syntax, but also the semantics. Remember at the beginning of the talk I said a clear contract, and you don't have the need to have deep knowledge to consume others' APIs. It's because contract includes the behavior interface and the behavior. But again, we need to be customer focused, and we need to invert the dependencies. We want to be consumer driven, because applying the dependency inversion at organizational level, not only in our code base, but also in the organization. You can find here the both parts of a contract. I need to speed up because we have 5 minutes. So we have the consumer part, and we have the provider part. And we need to have two tests to ensure we're checking our mocking assumptions. This is giving us same confidence, lower costs, they are easy to maintain, and they are very stable. Let's jump a bit talking about applying this to microservices. This is the archetype of a simple microservice, quite simple. You have the API versus level, you have the services, you have the domain, which is using or consuming other third parties, and relying on repositories to do the persistence. We need to check 3 things. Actually, there are 4. We need to check that the domain behaves as expected. We need to ensure that the domain collaborates as expected. And we need to ensure that consumed third parties comply with the contract, so we're validating or mocking assumptions. To test the behavior test, you stop the third parties and the repositories, and you focus on your services and your domain. To check the domain, you mock the third parties, maintaining the repositories with stubs. The third part, you need to do 2 things. The consumer part. So you check that your third parties are able to consume in a proper way the contract, and the provider part. You check that the resources of the API works properly with stubs services because of the contract you are having. How we can do that? I'm bringing you PACT. PACT is a library that implements consumer-driven contract testing in many languages. I want to show you a quick sample where we can connect 2 models, Move Money and Risk Engine. You have here the Maven configuration of those 2 models. The contract test of the Move Money. So we are creating a mock. We're adding a contract to that mock, an interaction of a contract of that mock, and we can test then the operation. Here you have the implementation of the interaction of the contract using PACT. PACT uses a little bit of Herkins given when then to define the interaction in between the consumer and the provider. And you can see here how simple it is to create a consumer test, contract test with PACT. So we're checking or mocking assumption of a high-risk operation. Here you have the REST controller using a Spring Boot of a simple API of the risk engine with the final implementation of the service, which is the risk engine, which is connected to 2 repositories. Okay? And you have here the provider contract test. That is, I prepare PACT to ensure the PACT is posting me to the API of the risk engine in order to validate a high-risk operation. And I prepare my service mock over here. This is the behavior test. This is the final test, ensuring that we are checking in a proper way the behavior of the risk engine. But I want to go quick to the takeaways, because I want you to think about tonight or tomorrow in your places what Jose was trying to say to me. So I want you to remember these takeaways. First, build decoupled software. This will let you to ensure you are able to maintain or even to improve your speed. Second, ensure you organize the team in order to promote the target architecture you want to achieve. Third, simplify your operations relying on a platform. Fourth, limit and manage your dependencies. Of course, write isolated tests better than integrated tests, and use those tests to check the integration points in order to ensure you're validating your mocking assumptions. Invert the dependencies in order applying consumer driven in order to be customer focused. This is the last slide. I have one shot, the last shot. Who wants to tell me what I'm trying to say with this image? Trust. What was autonomy? That can be decoupled. That brings you autonomy. but make sure you manage in a better way your operations, relying on a service mesh like Istio and using that is using Envoy, for example, like a sidecar. Limit and manage your dependencies, and of course, create a good test strategy using contract testing to ensure you are properly testing your platform. That's all. Thanks.